Dear student of class 11, now today I'll start the numerical problems of complex number, exercise 10. Now express each of the following complex number in the form of a plus iv. Now you can see over in a video the a plus iv is there. Now the given complex number that you have to write in terms of a plus iv form. Now sir, the given question is this one. Question number 1. It is question so part 1. Now you have to express this complex number in the form of a plus by b. Now I'll simplify this equation. 7 plus 3i plus into minus, it is minus 5 plus 2i. Now then I'll write first the real quantity. Real means which are the term which are independent of I. 7 minus 5 is 2, then 3i plus 2i is 5i. Now then I'll write these things in terms of a plus iv. A plus ib. Now it is in terms of 2 plus I into 5. Now in this case, a is 2 and b is equals to 5. Now the question is in terms of a plus iv form. Now similarly, I'll do question number 3. Question number 3 is 3 plus 2i. 3 plus 2i into 2 minus 3i. Now this equation also that you have to convert in terms of a plus ib form. Now for this equation, I'll multiply this to complex number. 3 2s are 6 algebraic multiplications that you have to do. 3 2s are 6 plus into minus, minus 3 3s are 9i plus 2 2s are 4i plus into minus, minus 3 2s are 6i into I square. Now then 6 minus 9i plus 4i is minus 5i minus 6 into the value of I square. In the theory also, in previous video we discussed these things. The value of I square is minus 1. It is 6 minus 5i minus into minus plus 6. 6 plus 6, it is 12 minus 5i. Now then it is 12 minus 5i. Now I'm going to write these things in the form of a plus iv. In front of the I, we must have a. Now then I'll write this expression, minus is there. I'll write plus I into minus 5. Now say a plus ib. In this case, a is 12, b is equals to minus 5. And this concept of to convert the given complex number in the form of a plus iv or a minus iv is an important concept. Frequently we'll use this concept in other numericals. Now dear student, this one is a little bit different. Question number 1 5. Again 13i over 2 minus 3i. You have to express this complex number in the form of a plus iv. And you just keep in your mind, in case of complex number, if it is numerator over denominator, in case of complex number, it is in the form of numerator over denominator, always rationalize the denominator. Always that you have to rationalize. Rationalize means you have to multiply both numerator and denominator by its conjugate pair. 2 plus 3i, then 2 minus 3i into 2 plus 3i. Numerator, I'll open this bracket, it is 13 into 2 is 26i plus 3 3s are 9, 3 1s are 3, I into I is I square. Now then it is in terms of formula. A plus b into a minus b, it is a square minus b square equals to 26i plus 39, the value of I square is minus 1, over 2 square is 4 minus 3 square is 9 into I square. Now then it is 26i minus into plus minus 39 over 4 minus 9 into I square is minus 1. Now then in numerator I'll write first real. 39 plus 26i over 4 minus into minus plus 9 minus 39 plus 26i over 9 plus 4 is 13. Now then I'll divide 1 by 1. 39 divided by 13 is 3 plus 2i. Therefore, minus 3 plus I into 2. Now it is in terms of a plus ib. A is minus 3, b is equals to 2. Now it is in terms of a plus ib form. If it is numerator over denominator, always rationalize the complex number. Now question number 2, find the conjugate of the following complex number. The first question number 2, 1 is 2 plus 3i. Conjugate, to calculate the conjugate, what you have to do is you just have to change the sign of imaginary quantity. Now say this one is the imaginary quantity. The sign of imaginary quantity is plus. Its conjugate will be minus. You just have to change the sign of imaginary. Then I'll represent this complex number. Let z equals to 2 plus 3i. Therefore, its conjugate means you don't have to write in words, you just write z bar means you are trying to calculate the conjugate. 2 and the sign of imaginary is plus. Now I'll write 3i. This one is the conjugate. Number 2 question. Question number 2 is root 5 minus 4i. Let z is equals to root 5 minus 4i. Therefore, its conjugate z bar will be, you just have to change the sign, it is minus, then I'll write plus 4i. This is how we are going to calculate the conjugate of a complex number. Now next is question number 3. To calculate the conjugate, let me different form is given over here. Now it is given 3 under root minus 2 minus 2 root 5. Now I'll consider let z is equals to this complex number 3 minus 2 root 5. Now then we did these things in theory. Under root minus 2 you can represent it by, if it is under root negative quantity means I root 2 we can write minus 2 root 5. Now first I'll write the real quantity minus 2 root 5. Now then I'll write the imaginary I into 3 root 2. Therefore, its conjugate, first of all you have to convert this one in terms of imaginary form, then minus 2 root 5, then change the sign, it will be minus I 3 root 2. Is the conjugate of a complex number. Now dear student, this question is important. Now it is in terms of numerator or denominator form of a complex number. Now what you have to calculate is find the conjugate of this complex number. Now before write the conjugate, you have to simplify these things. Now if it is numerator over denominator, I already told you you have to rationalize, then only you can use the property of complex number. Now z equals to 1 over I minus 1 minus I root 2. Then I'll use formula a minus b whole square. It is a square plus b square minus 2ab. Now then z equals to 1 square is 1 plus I square minus 2i. Now then z equals to 1 over 1. The value of I square is minus 1 minus 2i. So now it is cancelled. Now then z equals to, now we have z equals to minus 1 over 2i. Now then, for this kind of question, how to rationalize these things? Now that I'll rationalize this one, multiplying both numerator and denominator by I, then 2 into I square. Then z equals to minus I over 2 into minus 1 minus I over minus 2. Cancel. Now z equals to I by 2. Therefore, its conjugate will be minus I by 2. Dear student, question number 4 is very important. Find the modulus and amplitude. Modulus, amplitude, or modulus or argument that you get in examinations. It's the same thing, amplitude and argument. Now this one is the complex number. Find the modulus and amplitude. Let z equals to 1 plus I. Now say, once again I'll explain the theory. Now say z equals to 1 plus I, then the mode of z, let us suppose the complex number is z equals to a plus iv, then its modulus would be mode of z is equals to mode of a plus iv. When you remove the modulus, you just have to put square root, then a square plus b square. We are not going to touch this I. Mode of z is a square plus b square, only the real quantity, the sum of the square of the real quantity that we are going. And theta is the amplitude. Theta is equals to, let theta be the amplitude. Then tan theta is equals to b by a. Tan theta is equals to b by a. You have to calculate the value of theta. Now this is a complex number z. In this case, 1 plus I into 1 we can consider. I into 1. Then the mode of z, modulus of z means mode of 1 plus I into 1 mode. When you remove the mode, then what you have to do? A is 1, b is also 1. A square plus b square. Under root 1 square is 1, under root 1 square is 1. It is root 2. The modulus of this complex number is root 2. Modulus means we are trying to find the magnitude of a complex number. Now next is the amplitude. Let theta be the amplitude. Short form you can write AMP, amplitude. Therefore the amplitude is given by tan theta is equals to b by a. Tan theta. Now what is the value of b? From this complex number, b is 1, a is also 1. Then tan theta is equals to 1. If tan theta is equals to 1 means the value of 1 is tan 45 degree. Tan 45 degree is 1. Then removing tan from both the sides, we cannot cancel. Therefore, the theta is equals to 45 degree. This is amplitude. Modulus is root 2, amplitude is 45 degree. Now another question. Find the modulus and amplitude. Let z equals to minus 1 plus I. In this case, a is 1, b is also, a is minus 1, b is 1. Then the mode of z is given by mode of minus 1 plus I into 1. Then when you remove the mode, square of a and b, minus 1 whole square plus 1 square. Minus 1 whole square is 1 plus 1. It is root 2. And again, let theta be the amplitude. Let theta be the amplitude. Then tan theta is equals to b by a. Now the tan theta is equals to b. b is 1, a is minus 1. Now we have tan theta is equals to minus 1. And the tan theta is equals to minus tan 45 degree. Or we can write tan theta is equals to tan of minus 45 degree. Then theta is equals to minus 45. This is modulus and the amplitude. Now dear student, in your book the answer is not in this form. Answer is in terms of pi by 4. Pi means the value of pi in trigonometry is 180 degree. I'll do this by another method. Up to this it is same. From this I'll change the method. Now say tan theta is equals to minus tan 45 means we can write pi by 4. That means 180 divided by 4 is 45. This method is same. Only thing is the angle in a different form we are writing. Removing tan from both the sides, it will be theta is equals to minus pi by 4. Can you use answer like this or this? You'll get full marks. Now dear student, another question. Minus 1 minus I over 1 plus I. Find the modulus and amplitude. Directly we cannot calculate the modulus and amplitude if the complex number is in terms of numerator over denominator. First of all, you have to simplify this complex number. And you have to write this complex number in the form of a plus iv or a minus iv. Then only we can find the amplitude and the modulus. Now I'll simplify. Let z equals to 1 minus I over 1 plus I. If it is numerator over denominator, always rationalize the denominator. It is plus means I'll write both numerator and denominator by its minus quantity. 1 minus I. Z equals to 1 minus I whole square over, it is in terms of formula, a plus b, a minus b means a square minus b square. Then z equals to a minus b whole square formula, a square plus b square minus 2ab over 1. I square is minus 1, it will be plus 1. Now then z equals to 1. I square is minus 1. The value of I square is minus 1. Minus 2I over 2. Now z equals to minus into my plus minus 2I over 2. Cancel. Now the z equals to minus 2I by 2. Cancel. Now z equals to minus I. But we don't, this is in terms of minus I, so I'll write it is in terms of 0 minus I. 0 minus I is minus I. Now in this case, now say A is 0, I is, 1 is minus 1. Or we can write 0 plus I into minus 1. A is 0, B is minus 1. It is in terms of A plus I before. Then the modulus of this quantity, mod of z equals to mod of 0 plus I into minus 1. When you remove the mod, it will be 0 square plus minus 1 whole square. 0 square is 0 minus 1 square is 1. And the mod of z is 1. Mod of z is 1. Now next, the amplitude I will calculate. Let theta be the amplitude. Let theta be the amplitude of a given complex number. Then tan theta is equals to b by a. Then tan theta is equals to, substitute the value of b. b is minus 1 divided by a is 0. Now then, any number divided by 0 is undefined. And you know about these things. The value of tan undefined is tan 90 degree. 90 degree we can write in this form pi by 2. 90 means 180 divided by 2 is 90. Then theta is equals to pi by 2. Modulus is 1 and amplitude is 90 pi by 2. Now question number 8.1. If 3x plus y minus 4i is equals to 5 plus within bracket 2x minus 3y into I, find the value of x and y. Now say I'll use over here the equal complex number property. Suppose a plus ib is equals to c plus id. If these two complex numbers are equal, then the real quantities we can write equal. The real quantity is equal. A is equals to c. And these two are the imaginary quantity. Imaginary quantities are also equal. The same property that I'm going to use. Now, so in the left hand complex number, 3x plus y is the real quantity. In the right hand side, 5 is the real. That means real quantity we can write equal. 3x plus y equals to 5. Let it be equation number 1. Similarly, in right hand complex number, 2x minus 3y into I means this is imaginary. The imaginary quantity is 2x minus 3y equals to, what is the imaginary quantity over in our left hand complex number? It is minus 4. Let it be equation number 2. Now, after getting this two equation, we can easily calculate the value of x and y by solving simultaneously. solving 1 and 2. 3x plus y equals to 5, then 2x minus 3y is equals to minus 4. I'll multiply this equation by 3 to cancel this y quantity into 1. 9x plus 3y is equals to 5 3 is a 15. Then it is 2x minus 3y is equals to minus 4. Now then no need to change the sign, this will cancel out. Now so 9x plus 2x is 11x equals to 15 minus 4 is 11. Cancel, the value of x is 1. Putting x equals to 1 in equation 1, putting x is equals to 1 in equation 1. I'll substitute in equation number 1. 3 into 1 plus y equals to 5. Then 3 plus y is equals to 5. Y is equals to 5 minus 3. Y is equals to 5 minus 3 is 2. Therefore, x equals to 1, y is equals to 2. This is the required answer using equal complex number property. Now another important question, if x plus iy is equals to the complex number numerator over denominator, find x and y. Now what you have to do is to use equal complex number property. This you have to rationalize, and then after the rationalization that you have to convert this right hand side complex number in the form of x plus iy form. Then we can equate. Now x plus iy is equals to, now if it is numerator over denominator, I'll rationalize the denominator. Over now then multiply this to root 3 into root 3 is 3. 3 to the 6. Now this 2 plus I, root 3 into root 2 is root 6 minus, this one will be I 2. Root 2 into root 3 is root 6, minus into plus minus, I into I square into root 2 is 2. Over, it is in terms of formula, a plus b into a minus b. Formula would be a square minus b square. Now x plus iy is equals to 6. Then I root 6 minus 2i root 6 is, subtract these two, it will be minus I root 6, and the value of I square is minus 1, it will be plus 2 over 2 square is 4, root 3 square is 3, 4 3 is 12, minus I square into root 2 square is 2. Now x plus iy is equals to 6 plus 2 is 8 minus I root 6 over 12. I square is minus 1, will be plus 2. Now then x plus iy is equals to 8 minus I root 6 over 14. Then x plus iy is equals to 8 by 14. It is plus, I'll write also plus over here, plus I root 6 over 14. X plus I y, it should be minus over here, so that minus into plus is minus. 2 4s are 8, 2 7s are 14. Then x plus iy is equals to 4 by 7 plus I into minus root 6 over 14. Therefore, equating the real, x equals to 4 by 7, then y is equals to minus root 6 over 14. This is a required answer, the value of x and y. Dear student, this was for today. I did up to question number 8, and I left some questions. Try leftover sums. If you face any problem in leftover numericals or the videos numerical, directly you can contact me in my WhatsApp number. Thank you.